Welcome to day 3 of our 100-day SAT Math Challenge. In today's video, we're going to be discussing linear equations, what they are, how to solve them, how to graph them, and also real-world applications of linear equations. So let's start with defining a linear equation. What is a linear equation? Simply put, a linear equation is an equation that is represented by a straight line. And also it's in the form ax plus b equals to c, or in the slope-intercept form, it is y equals to mx plus b, where the m is the slope and the b is the y-intercept. For example, in day 2, we had an equation 3x minus 7 equals to 11. This is a linear equation because we can represent it by y equals to 3x minus 7. All right, and here the slope of the line is 3 and the y-intercept is negative 7. All right, now let's see this graphically. What does this mean on a graph? Remember, a linear equation is an equation that is represented by a straight line. So how do we draw this on a graph? So let's have a graph here where you have the horizontal axis representing x values, while the vertical axis representing y values. Now, at this end, you have the positive y values, you have positive x values here, you have negative y values here, you have negative x values here. Okay, so the y-intercept, let's start from there. The y-intercept is where the line crosses the y-axis. So now for here, the line crosses the y-axis at negative 7, y equals negative 7. At the y-intercept, the value of x is 0. So this represented on the graph is 0, negative 7. It has no value on it. The value is 0 on the x-axis and negative 7 on the y-axis. So negative 7 is somewhere around here. So this is that point B here. This is where the line crosses. Now the slope is given by 3. The slope is given by 3. Now we can identify another point on this graph by substituting a value of x, any value of x. For example, if we say y is 3, for example, if x is 3, what is y? Y will be 3 times 3 minus 7. So y, 9 minus 7, which is 2. So we write that as 3, 2. The y-intercept is written as 0 minus 7. So we can plot this also on the graph. When x is 3, 3 is somewhere there around here, because this is 0 here, this is 1, this is 2, and that is 3. On the y, we have 1, we have 2. So when x is 3, y is 2. This is another point on the graph. Then we can join those 2 points together. If we join those 2 points together, this is the line. This is the line. This is the equation of 3x. Y equals to 3x minus 7. Now, in day 2, we solved 3x minus 7 equals to 11. And we got the answer as 6. So that means on the graph, it will be represented by x is 6, y is 11. So we can represent that on the graph by, if this is 6.6 here, when you trace that up, the value of y is 11, so somewhere around here. All right, you get the point. Of course, this graph is not drawn to scale, but you get the idea. Okay, so this is how you graph linear equations. They help you see the solutions graphically. All right. Now let's look at a real world application of linear equation. Let's say you are saving some money. Maybe you want to buy, some a new phone that you can use for Instagram and TikTok. And you started saving, but you started with $200. All right. You started with $200. Then based on the work you do, you decided, okay, I will be saving $10 every week. $10 every week. All right. We can represent this by a linear equation. If y represents the amount saved and x represents the number of weeks, the weeks. All right. Your amount saved, y, will be m, 10, the amount you save per week, 10 times x, plus 200, the amount that you started with. All right. Now, let's say you've been saving for 20 weeks now. All right. 20 weeks is about 5 months. So how much do you have at the end of 5 months? Y would be 10 times, remember x is in weeks, so 5 months is 20 weeks, plus 200, which is 200 plus 200, which is $400. Y is amount saved in dollars. So at the end of 5 months or 20 weeks, you've saved $400. That may be enough to get you a refurbished iPhone. So you can go ahead on Amazon and order it, right? This is linear equation at work. It has helped you identify the amount you would have at the end of 5 months, so you'll be able to know whether you'll be able to get your iPhone at the end of 5 months. Very cool, right? Awesome. Now, let's look at how to solve a complicated linear problem like 2x plus 5 equals to 3x minus 1. Let's write it here. 2x plus 5 equals to 3x minus 1. Let's find what the value of x is. Now, to find the value of x, group all the like terms together. Group all the terms that look alike together. For example, 2x and 3x look alike, so you group them together. 1 and 5 look alike, so you group them together. All right. So how do we do that? Now, 2x is here. If you bring the 3x over to this side, it becomes a negative. It was previously positive here, but when it comes towards 2x to the left hand side and over the equals symbol, it becomes negative. Then equals to -1. If you bring the 5 to the right hand side, it becomes a negative because it was positive here, and when it goes over the equal sign, it becomes a negative. 2x minus 3x is -6, minus 1 minus 5 is 9 minus 6. This cancels out and you have x equals 6, and that's your answer. Let's verify. If what is 2 times 6 plus 5? That is what? 17. Is it the same thing as saying 3 times 6 minus 1? Yes, it is also 17. All right, so we see the value of 6 solves this problem. All right, so today we discuss linear equations, what they are, how they can be represented on a graph, how to solve them, and how to identify slope and y-intercept, and also real-life applications of linear equations. Thank you so much for watching. We've wrapped up to day 3. Make sure you go and watch day 2 if you haven't yet. And in the next video, we're going to be solving systems of linear equations. Make sure you subscribe and also check out my TikTok for a brief introduction to linear equations. Stay tuned, and I'll see you next time.